is indirect measurement. Okay? And indirect measurement means you're not directly going up to something and measuring it, because sometimes we can't. Okay? There are certain things that I cannot walk up to with a ruler and measure. Okay? And so then we have to do something called indirect measurement. Like, it's going to be really hard for me to walk up to a tree, like a really tall tree, and measure it. Why? Why would that be hard? Get a ladder. What if I don't have a tall enough ladder?
Go around something.
I'm not good at climbing trees. Some of you might be. I have a child that's good at climbing trees. Seriously. If I can't find him in the summer, I just look in a tree because he's brecking. He's probably somewhere up a tree. But I'm not good at climbing trees. So if somebody wanted me to measure a tree, that wouldn't really work too well. Okay, so suppose, here's a scenario. Suppose we went on a class trip to Washington, D.C. Okay? The school was going to send us on a class trip. While there, you have to do a little bit of math, a little bit of English, because it's, for school. So, you're going to measure the height of the Washington Monument. Okay, now here's the thing. You can't go, climb the Washington Monument. You get in a lot of trouble. Can't do that, okay? And the only thing I give you is a ruler. I didn't give you a ladder. I didn't give you anything else. I only gave you a ruler to measure it with. Any ideas how you can figure out the height? Jada. Yeah, you could maybe try to guesstimate it, but I want you to be accurate. So I want a pretty accurate measurement of the Washington Monument. Any ideas? This is all I'm sending you with. I'm going to give you guys this little plastic ruler and go measure the Washington Monument. Carson?
Ask someone who knows what the answer is.
No, sorry. It's not good to talk to strangers. So you can't do that.
What about Google?
No, I took all your phones. Sorry. No Google is available.
There must be one computer there.
No, there's not. They shut off Wi-Fi for all of Washington, D.C. Sorry.
What?
You're out of luck.
What? Data.
No. Okay, so how many of you are thinking that's impossible in itself, and you can't do that? Okay, actually it's not impossible. Okay? We're going to assume it's a nice sunny day and that there's a shadow. Okay? Because it would be very easy for any of you with a simple ruler to go measure the monument's shadow. So you don't have to climb it. Don't do anything crazy like that. We're just going to measure its shadow. Okay, Carson?
Isn't the shadow going to be in the water?
It's going the other direction.
What if it's
Stop being so technical.
What if the shadow's in the wrong?
I'm not talking to you anymore. Okay, so we're going to use the shadow, but we also need another object. Okay, and that might be a friend. Because you could know your friend's height and their shadow so that we can make a comparison. Okay, so by indirectly measuring, that's how we're going to do it. We're measuring using shadows and heights. Okay, so it ends up being things like this. If an object is outdoors, you can use shadows to help estimate the height. And now it's not going to be perfect, but it's going to be closer than just guesstimating.
That was her.
Okay, much closer than guesstimating. On a sunny day, an object casts a shadow. So the diagram below shows how a flagpole and the tree and the corresponding shadows create similar figures. Okay. Now, you have to be pretty quick because you can't have the sun moving a whole lot or the shadows change a lot. Okay, so that's why we'd have to work as a class and get quick measurements.
What if it's a cloudy day?
It's not. It's a sunny day. It's always sunny when you're on vacation.
Sure.
Okay, that's what I'm going to believe anyway. Okay, so you can see from this picture that ultimately we end up with two triangles. Right? And the two triangles are similar to each other. Now, if I wanted to find the height of the tree, maybe I know the height of the flagpole. Maybe I know the flagpole is 9 feet tall. And I can measure its shadow, and maybe its shadow is 7 feet. I can measure the tree's shadow. Maybe it's 14 feet. We could then use all of that information to find the height of the tree. Okay? So drawing that simple diagram using shadows and heights are going to help us find the height of the object that we want. Okay? So on to the next slide. Okay, everybody should be able to see this in your notes, right? This is the 4th slide on your notes. Right? You get to the right page here? Yeah. Slide 4. Okay? It says, John is standing in his front yard. His height is 5 feet tall. His shadow is 8 feet long. If his little sister is 4 feet tall, how long will her shadow be? Okay, we are going to draw a picture. You guys are going to be really impressed with my drawings. I'm a really good artist. Not really. I'm good at drawing stick people. Okay? So, here is John. Okay, I'll even give him some hair.
High quality artist.
Okay? I gave him a nose. He's got 2 eyes, a nose, and a mouth. Can't you see? I'm a good. Don't criticize my drawing. Otherwise, I cry at night, and it's not good. Okay? So, there is John, and he is 5 feet tall. And it says his shadow, there's his shadow, is 8 feet long. Draw this. I'm pretty sure your drawings are not going to be as fabulous as mine,
Ever.
but try. Give it your best effort, okay?
I won't have the arms and
Those of you at home, draw your beautiful stick people, okay? Again, I'm sure they're not as good as mine, but you can try. Okay, then we have his little sister, so here's his little sister. Whoops. It's his sister, so she gets long hair.
Sister looks like she's 3 feet tall.
Oh, be quiet. She's got kind of a messed up smile and face right now, but it's okay. Okay, and she is 4 feet tall. The question is, how long is her shadow? Okay. So the picture helps us set this all up. What are we comparing in this problem? What are we comparing? Anyone? Anybody at home know what we're comparing? Anybody here? Because you're too busy drawing yet. Jada. Okay, we're comparing the height of the person to its shadow. Okay, so when you see problems like this, what we are comparing is we are comparing height to shadow. Okay? We're comparing the height of the person to its shadow. So I'm going to put in front of this proportion H over S. Height over shadow. So then I'm going to pick the numbers. John is 5 feet tall. His shadow is 8. 5 to 8. His sister is 4 feet tall. Height to, we don't know her shadow. That's where we put the X. Okay, so we're comparing height to shadow. Now we have a simple proportion that we can solve. This is where your calculator comes in. Okay, 8 times 4 divided by 5. Multiply the 2 numbers on the diagonal and divide by the third number. So you get 6.4. So her shadow is 6.4 feet. Questions there? That kind of makes sense? So indirectly, we're measuring it. Okay? We didn't actually have to measure her shadow. We had to measure his shadow, his height, but then we could figure out the rest. Okay, here's another one. Again, I'll make another fabulous drawing. A building that is 24 meters tall casts a shadow that's 16 meters long, while the taller building casts a 24 meter long shadow. What's the height of the taller building? Okay, so we have 2 buildings. There's my first building. There's the door. Some windows.
Beautiful.
Awesome. It is. Don't talk to Miss Asselson or Miss Anderson about my artwork because they might wonder.
Knocking down your door.
Okay.
I
All right, so this building
You
is
need to be a professional
24
artist.
meters tall and its shadow is 16 meters long.
8,000.
I know you guys are all impressed that I can draw so well.
You need to be an artiste.
Yeah, I'll stick to a math teacher. Okay,
Oh.
a taller building. There's my taller building. Really, I wouldn't have to put any windows or doors. I could just draw a box. Okay, cast a shadow. Oh, goodness gracious. Cast a shadow that's 24 meters long. Okay, so you guys, your pictures don't have to be nice. They don't have to be perfect. But you need something so you know where to put the numbers. That helps us organize our data. We're trying to find the height of the taller building. What are we comparing in this problem? Just like the last one, we are comparing the height of the building to its shadow. Okay, height to shadow. So same type of thing. So when I set up the proportion, I'm going height to shadow. I'm going to look at the first building. The height of the first building was 24. Its shadow was 16 meters. Okay, the second building, we do not know the height, but we know its shadow is 24 meters. And now we grab our calculator and we're going to solve it. Okay, we multiply the two numbers on the diagonal. Always multiply those two numbers first. 24 times 24. Divide by the third number. Divided by 16. The taller building is 36 meters tall. There's your answer. Questions there? Any questions on that one? Okay, we're going to skip the next one. Okay, cross out this one. For sake of time, we're going to skip that one. Okay? I want you to flip to the next page. And I want you to try this one on your own. Flip to the back side of your page. Okay, those of you at home, flip to the back side. It says a lamppost casts a shadow that's 35 yards long. A 3-foot tall mailbox casts a shadow that's 5 yards long. How tall is the lamppost? So start by drawing a picture. Okay. You have a lamppost and a mailbox. Label both. Set up your proportion. You're comparing the height to the shadow. Oh, you put the little rays on it? How artistic. Okay, see if you can figure out how tall the lamppost is. Those of you at home, once you've got it, put it in the chat. Or you could keep your day job of being a student. Too bad.
Do we get paid to do this?
Yeah, someday when you get a job, you'll be glad that you had an education.
Work with my dad all day.
Yeah,
You
that's
still
what
need
I
to
did.
concrete.
Oh, you still need to know a whole lot of math to do
I
that.
did concrete.
Good
I'm
enough.
pretty sure if you talk to your dad about how much math he uses, he uses a lot.
I'll just use this math. That's good enough.
Yeah.
Krista, you got it.
I got it.
I know what it is.
I know it.
21.
Yeah. Keep figuring it out though on your own. See if you come up with that.
Okay, fine.
Ethan, you got it.
So smart.
I only drew the lamppost and I got
Keep
the
going,
other.
Carson.
21.
Matthew, you got it.
There. Done.
Riley, you got it.
Oh, copycat.
I gotta try to improve my artistic abilities somehow.
See, that's what I mean. I'm a better drawer than you. You're taking it.
Okay. So let's run through this. There's my drawing. I have my lamppost and my mailbox and their shadows.
21.
Okay. The lamppost has a shadow that's 30. Whoops, not 25. 35 yards. The 3-foot mailbox casts a shadow that's 5 yards. Okay. Now, some of you may have noticed that the labels don't match. Did anybody notice that?
No.
Notice that these are both yards, but the mailbox is feet.
Oh.
That's okay.
Okay.
That's okay. As long as the label on the height of the lamppost is also feet.
Feet. Could you just put one?
Right?
21 feet.
Because then we're comparing feet to yards, so that's okay. So we're comparing the height to its shadow. Okay, the height of the lamppost we do not know. Its shadow is 35 yards. The mailbox is 3 feet over 5 yards. Okay, so even though our labels don't all match, they have to match across or up and down. They have to match in at least one direction. And so we're going to make them match across. So that means the top is always going to be feet. So then we solve this, 35 times 3, and then divide by 5, you get x equals 21 feet. So the lamppost is 21 feet. Now, if you would have said the lamppost is 21 yards tall,
That makes sense.
that makes no sense at all. 21 yards is an extremely tall lamppost.
Isn't that like
That's more like an, I don't know,
That's from the goal
Yeah.
line to the 21 yard.
that's like 63 feet. I don't think lampposts are 63 feet tall.
Jeez.
Okay? So that's why that label has to be feet. Okay, let's look at the next problem. So this time it looks a little bit different. Sometimes we want to know distances that we physically can't measure, like the distance across a river. Okay? That's going to be pretty hard to measure because, well, depending on how big the river is, or we don't want to maybe go across the river. You get all wet.
Tape measure.
Okay? It maybe doesn't work that well. Okay, your tape measure probably isn't long enough.
Bridge.
So, yeah, you're just gonna build a bridge. Like, yeah, whatever. Let's grab some wood, build a bridge. It doesn't, you don't even know how much wood you need because you don't know how wide the river is.
Just keep building.
So, he drew a diagram. So we have this diagram that is labeled with the measurements listed. Okay, so then we're gonna try to figure out what is the distance across the river. Now, this diagram gives me 2 similar triangles. One is just rotated. Okay? So we have to match up. I'm going to label these 2 triangles A and B. And when we set up our proportion, we're going to compare A to B. Okay, so I'm going to pick a side on A. It doesn't really matter what side. I'm going to pick the 24. Which measurement from triangle, or does 24 match up with on triangle B? Does it match up with the 72 or does it match up with the question mark? Carson says the question mark. He's right. Okay. These are matching measurements. They're the distance across. Okay, so the 24 matches up with X or the question mark. Make sure you're writing this down. Okay. The 18 along the shoreline then matches up with the 72. So 18 over 72. Okay, so you're really just having to match up corresponding sides again. And solving this proportion, multiply the 2 numbers on the diagonal. 24 times 72 divided by 18. 24 times 72 divided by 18. X equals 96 what? How would I label that? Meters. Everything in this problem is meters. So the distance across the river is 96 meters.
You
Good
need,
luck
you need
building
a
your
96
bridge.
All you
meter length
needed-
tree. And then,
Yeah, all you needed to
Sure.
do was get an
Chop it down.
100 meter board and go. It's not
Uh-huh.
that hard.
Uh-huh.
Wow.
Sure, not that hard. All right. Okay,
Swim.
questions on that one?
Yeah.
One last problem to do and then you'll have some work time. Okay, so this time Tamara wants to know the width of the pond at the park. So she drew and labeled the diagram. She obviously was not getting in the pond because, you know, ponds usually are like the green, mucky, it gets
Okay.
gross. No, we don't want to go in there. That's disgusting.
I would go.
Yes. Okay, so she drew and labeled the diagram. Everything she labeled is measurements she could make on the ground. Okay? So we want to figure out how wide the pond is. Okay, I'm going to label my two triangles, A and B again. And we're going to match up our corresponding sides. So I'm going to pick the 36 first. The 36 matches up with which side? So now you have to recognize that you kind of have to rotate. You have to take this bottom triangle and rotate it around. And so it matches up with the 9. So we'd have 36 over 9. Okay, and again, you should be writing this down. And then we have the question mark matches up with the 15. So x over 15. Okay, from that point, it is simple solving the proportion. Multiply the two numbers on the diagonal, divide by the third number. So 36 times 15 divided by 9, x equals 60 yards. So the width of the pond is 60 yards. Okay? Questions there? Any questions from anybody? That relate to the math, not to jumping in a pond or
Oh.
Carson.
You said you didn't want to get wet. Why is the line in the middle of the pond?
She didn't actually measure that. That's the, she measured this line and this line and this line.
Why she want to know how
She didn't have to
big
go
it
in the
is?
water at all.
Yeah, let's-
Okay.